This unit is all about something called conics. Conics are shapes created by the intersection of a plane with a cone. So you can see the four shapes we'll be dealing with. These are the four main conics for sure. And you can see there with the shaded blue plane passing through this double cone they have showing. You see the parabola happens up in the top left, a circle in the top right, an ellipse, which we think of more as an oval, but it is not an oval truly. It's an ellipse, but it's similar to an oval in the bottom left, and then a hyperbola in the bottom right. So that's where the term conics is coming from, because it's about intersection of a plane with a cone. But we're just going to focus first on circles. So circles are familiar to you for sure, but we want to start with the basics. So first of all, the definition of a circle. A circle is the set of all points that are equidistant from a single point called the center. Now here's one reason this is important. Sometimes when we think of a circle, we really think of it as more this whole thing, all of it. But technically speaking, that is not the circle. The circle is just the points that form the edge of the circle. So it's really just this outer line right here. That is the circle, just those points. Now the radius is the most important piece for our purposes anyway of the circle, and that is the distance from the center to any point on the circle. That's one reason it's important to define what a circle is, because if we really thought of it as the whole thing, then I could say, oh well, the radius is the distance from here to here, because that's a point on the circle. But we know it's not. The circle is the outer edge, so it's the distance from the center to the outer edge, or really to the true points on the circle. Now this equation down here, this is the formula for a circle. X and Y are the same variables they always are. The H and the K are the X value and the Y value that form the center of the circle. So HK is the center, and notice we are subtracting. So if this was X minus 3 right here, and this was Y minus 4, then the center would then be 3, 4, because we're always subtracting the value. If they were plus 3 and plus 4, then the center would be negative 3 and negative 4, because we're subtracting the negatives to make it a positive. So make sure you lock these in your brain. This is the equation for a circle, and make sure you know what part of it is the center. And the R over here is the radius. So with the center and the radius, you can always form the equation of a circle. That's really what we'll focus on, is making sure we can find or we have the center and the radius. So first example, we want to write the equation of a circle with a center, negative 2, 5, and a radius of 3. So I'm just going to write the basic form here first. This is what we're wanting to fill in, and we need to fill in the circle and the radius. Excuse me, the center and the radius. So we subtract negative 2, that's a plus 2. We subtract 5, and the radius is 3, so we're going to go ahead and square that and write it as 9. Next up, write the equation of a circle with a center at 7, 1, and 12, 1 is a point on the circle. Okay, so notice what they're giving us. I'm not going to graph this truly, just to give us an idea though. We know the center is at 7, 1, and they're telling us the point 12, 1 is on the circle. So remember, to write the equation, the two things we need are the center and the radius. Now they gave us the center, so we could go ahead and write that part. We know the center is 7, 1, so we can do x minus 7 squared plus y minus 1 squared. But we don't have the radius. We can find it though by finding the distance between these 2 points. Now this one's pretty simple, because since the 1's are the same, we know we just need to say, okay, how far is it from 7 to 12? That's a distance of 5, so my radius is 5. I do 5 squared and get 25. Now there will be times, and we'll see this in a minute, where it won't be as simple as for example, the two y values being the same, meaning we can just do 12 minus 7 to get it, there are times we'll have to use the distance formula in order to find it. But here is our equation for this circle that is described. Okay, this one says write the equation of a circle that is tangent to the y-axis with a center at 3, -2. Alright, so 3, -2. 3, -2 be about here, and it tells us it's tangent to the y-axis, so about like that. What that's going to allow us to do is find a point on the circle just like we did on the previous example. So if it's on the y-axis, we know the x value has to be 0. Think about it, everything along the y-axis, the x value is always 0. And since it's right in line with this other point, we know this would be the point 0, -2. So we have the center, just like before, so x minus 3 squared plus y minus a -2 squared. And then to get the radius, we can again, fortunately, say, alright, these are both -2, so we just need to know what's the distance from 0 to 3. Obviously it's 3, so 3 squared is 9. So when you're tangent to the y-axis, it actually ironically turns out it's the distance between 0 and the x value that will help you find the radius. Now, find the equation of a circle with a center at 0, -3 that is tangent to x equals 2. Okay, so similar idea here. We have the point 0, -3, so somewhere in that area. And we have the line x equals 2, can be around here. So I have a circle that goes something like that. Okay, so the center is at 0, -3. Again, that part's good to go. It's minus 0, so I don't really have to write that. I could just write x squared. And then plus y minus -3 squared. And we'll have to find the radius. Okay, so I'm going to go ahead and write this a little better here. Okay, but to get our radius, we need to know the distance from here to here. Well, this is x equals 2, so we know the x value has to be 2, because it's the line x equals 2. And it's right in line with this other point, 0, -3, so it has to have the same y value, -3. So this one, the radius is 2, because again, these two are the same, so we don't have to worry about those. But the distance from 0 to 2 is 2, so the radius is 2, giving us a 4 when we square it. So when you're told it's tangent to a line, you need to think, alright, what do I know about that line? If it's something like x equals 2 or y equals 2, well, you obviously know the x value or the y value for the point. If it's an axis, like it was in this previous example, if it's the y-axis, it's always going to tell you that x equals 0. If it's the x-axis, it's always going to tell you that the y value is 0. Just one more example for this lesson. Save the best for last. Write the equation of a circle that has a diameter with endpoints 3, -1 and 5, -5. Okay, this is where we get the fun of putting it all together. So this isn't going to be a perfect graph, but I'm just going to give us a basic idea. Let's say this is the point 3, -1. Excuse me. This is the point 5, -5. So we were not given directly the center or the radius, but since this is the diameter, we know the center of the circle would have to be exactly in the middle of these two. So the way we can find the middle of a line segment is with the midpoint formula. So I will add the x's together and divide by 2, and I'll add the y's together and divide by 2. So that gives me 8 over 2, which is 4, -6 over 2, which is -3. So now I know the center. The center is 4, -3. Okay, now the radius is the distance from the center to the edge of the circle. So here you actually have three options. I'm not going to do all three, but I just want you to know you can do three different things. First choice, you could do exactly what I drew. You could find the distance from 4, -3 to 3, -1. But if for some reason you wanted to, you could also do the distance from 4, -3 to 5, -5, because that's also the distance from the center to a point on the circle. But one other option, and this usually happens if you end up with decimals in the center and you don't want to mess with those, you can find the distance across the whole diameter between these 2 points we were given originally, but then you just have to remember to cut your answer in half. But as long as you cut your answer in half, if you're finding the diameter, you'll get the radius. But either way will work just fine. Okay, so I'm going to do the very first option, find the distance from 3, -1 to 4, -3. The distance formula, I do the square root of the x values being subtracted squared plus the y values being subtracted squared. So I get -1 squared, and then -1 plus 3 is 2 squared. So I get 1 plus 4, and that is 5. So we get the square root of 5 as the radius. Now, we can write the equation now that we have all the pieces. Again, we use the distance formula to find the radius, and we use the midpoint formula to find the center. So we have the center, 4, -3, and we have the radius, square root of 5. So our equation will be x minus 4 squared plus y plus 3 squared equals, and leave it as the square root of 5 because since we square the radius, that makes it really easy. It's just 5. Square root of 5 squared is just 5. So if you're ever asked is what is the radius, please just leave it in the square root form because that keeps it more exact, and since you're going to be squaring it when you put it in there, that makes it really easy. That is circles, part 1.